Welcome to an explanation of SureMass features, and we will talk about the performance of SureMass and a little bit of the explanation of how it gets around to improvements in answers like dynamic range. As a bit of background with SureMass features, it's worth understanding that there is a 3D dimension to profile scan data. So looking at the scan times, you can see that scan indices represent spectra. This is the flight time and time of flight. And you can see the emerging peak. From a quantitation point of view, we're interested in that peak, and a peak has a well-defined retention time here assigned. We get a defined M over Z value, and it has this abundance profile which we use to integrate and find its area. In terms of finding that 3D peak in that scan profile data, I'll make an analogy here between finding mountain ranges. Mountain ranges have ridges, and instead of looking for them kind of a random way, I can look for the existence of ridges. And I would find that ridges follow a certain pattern in the same way that there's ridges of masses that appear. And we'll see that in the diagram in a moment. In this 3D representation, you can see that if we cut across by mass, flight time, you'll see three distinct features here, 1, 2, and 3. If you were to look at this from the point of view of the analogy of ridges, here is a feature. And that feature is shown here in this diagram. Now let's note that a feature is different than a EIC, extracted ion chromatogram. Following along with the ridge analogy, the mass can drift. So it's not the same as taking a fixed mass extraction window, because the algorithm is smart enough to follow that mass drift, whether it be due to temperature fluctuation or the detector phenomena. The algorithmic treatment is able to capture this ridge and return an integratable peak. From a quantitation point of view, there is a similarity between EIC, extracted ion chromatogram, and SureMass extraction. Both of them are going to look at a retention time range and then look for a mass. In the case of SureMass features, it will return features where the assigned mass is in that mass extraction window. That is different than the EIC approach, which is looking for that ion across time in that window. If the mass were to drift outside that window, you could see a non-Gaussian peak shape. It's important to understand that difference because, for example, when you're doing SureMass, you don't have the choice of parameter integrators because the algorithmic treatment of SureMass finding the features uses the internal parameterless integrator. So there are differences that you'll see in manual integration, for example, with SureMass versus the extracted ion approach. Thanks for your attention.